Good day, viewers all over the world. You are welcome to Toydel online class. So we want to look at further examples on type 4 partial fraction. Type 4 partial fraction is the partial fraction in which the power of the unknown at the numerator is greater than that of the denominator, or where the coefficient of the power of the highest power at the numerator is more than the coefficient of the highest power at the denominator. Look at this question now, where we have 3x minus 1, 3x minus 1 into bracket 2x minus 1 all over x squared plus 4x minus plus 3. So if we expand this numerator, what are we going to get? We are going to have something in form of 6x squared minus 3x minus 2x plus 1. That will be minus 5x plus 1 all over x squared plus 4x squared plus 3. That's what you're going to get. You realize that they have the same degree, the same power, but the coefficient of the highest degree at the numerator is more than the denominator. So we first use non-division method. I'm going to have 6x squared minus 5x plus 1 divided by x squared plus 4x plus 3. That's what I'm going to get. What will I use to multiply this with? I'm going to have something in form of 6. Then I'm going to have 6x squared plus 6 times 4, 24x plus 18. So there will be this natural minus that comes in. Then here will become minus 24. I'm going to get minus 29x. Then this will be minus 18. This will be minus 24. So minus 29x. Then minus 18. That will be minus 17. That's what I'm going to get. So how do I now resolve this in partial fraction? We are going to say that 3x minus 1 into bracket 2x minus 1 all over x squared plus 4x plus 3 will now be equal to the remainder 6, the result 6 plus the remainder, that's minus, so in this case now, minus 29x minus 17 all over the divisor x squared minus plus 4x plus 3. So we cannot resolve everything directly into the partial fraction, but I can rewrite this. What I'm trying to say is that I can rewrite this. That is, in this case now, I'll just rewrite this. I'm going to have 6. This minus can come out. I'll have minus, then I'll be left with 29x plus 3 at the numerator all over x squared plus 4x plus 3. So this is the first step. So minus can come out. If I bring out minus, this is 17. If I bring out minus, that's what I'm going to get. So this is the first step that we are going to take before we resolve into partial fraction. So once we have taken this step, then what we'll be left with is that we will now resolve this. Is this we resolve into partial fraction? I will have 29x plus 17 all over. Can I factorize this? Yes. Is it factorizable? Yes. That's x squared plus 3x plus x plus 3. So we do that. That's x plus s. That will be s. X is our common s plus 3, then plus 1 into s plus 3. So instead of what I have here now, I will change this. This will now be resolved as x plus 1 into bracket s plus 3. So if I expand this, I get this. Then since this is what I have here now, then this is example under type 1 partial fraction. I'm going to have a all over the first factor plus b all over the second factor. That's what you're going to get. So if I multiply through by the coefficient, by the factors of the denominator at the left hand side, I'm going to have 29x plus 17 to be equal to a into bracket x plus 3 plus b into bracket x plus 1. Then at this point, I can use cover-up method to get whatever the value of the unknown that I have. If I put s, let me say I put x to be equal to minus 3, I'm going to have 29 into bracket minus 3 plus 17 to be equal to minus 3 plus 3 will vanish. Then I will have minus 3 plus 1, that's minus 2b. So 29, this will give me minus 87 plus 17 is equal to minus 2b. So minus 87 plus minus 87, this will give you minus 70 to be equal to minus 2b. Divide both sides by minus 2, minus 2. This will cancel this. Therefore, my b will be equal to 35. So I've gotten the value of b to be equal to 35. Then what will happen is that I'll go ahead and find the value of a. So how do I get the value of a? I'll go back to what we are given. So in this case now, the value of a, I can get the value of a here. If I put x to be equal to here minus 1, I'm going to get 29 to bracket minus 1 plus 17 to be equal to, if I put x equal to minus 1, right? 3 minus 1, that will be 2a. Minus 1 plus 1, that will vanish out. Okay? Then here I'm going to have minus 29 plus 17 to be equal to 2a. Then from here, I will get minus 12. That's minus 12 to be equal to 2a. I will divide both sides by 2. Let's divide both sides by 2. So a will be equal to minus 6. So we have gotten the value of a and b. So since we have gotten the value of a and b, then we can go ahead and rewrite the solution. A, let's write it somewhere here. A is equal to minus 6 and b is equal to 35. So let's now go back to the drawing board. So here we are going to have the value here will now be equal to 6 minus 29 x plus 17 all over x squared plus 4x plus 3. And of course, we have gotten the value of x squared, we have gotten this value to be equal to x plus 3 and x plus 1. That's what we have got. We have gotten the value to be x plus 1, then x plus 3. We have gotten that. So at the end of the day, we have it to be equal to 6 minus, we have a all over x plus 1, then plus b all over x plus 3, or something of this nature. So when we multiply through, we have something of this. So at the end of the day, the final answer will be x minus a. A is minus 6. So I will have minus, that will be into bracket, minus 6 all over x plus 1, then plus b is 35. 35 into bracket x plus 3. That's what you are going to get. So if I rewrite that correctly, at the end of the day, the final answer will be 6 minus 6. That was 6 plus 6 all over x plus 1, then minus 35 all over x plus 3. That will be the final answer that we are going to get. Thank you.